Oh, hi guys. Just a quick recap of what we have done. So, in the we I've given you a brief presentation as lecture one and about CFD, and we have lesson one ICM CFD geometry and lesson two meshing and airfoil, and I just did a lesson three on what we did today. So steady state simulations using Fluent, and we used cylinder domain in a steady state iterative solution rather than an actual physical time forward in simulation. And I talked about how to visualize the results in Fluent and how to pass forward the data into CFD post, and I was going to do another tutorial on CFD post, but I thought that it will be more appropriate to do such a thing after we have results for a 3D configuration, so we can use the cut planes and all these scan planes, and we use it's going to be more complicated than for a 2D configuration. So today I just wanted to do another tutorial on using ICM CFD for meshing a 3D wing. So basically the NACA 12 wing that we had on that I had uploaded on the Dropbox. Let's go into Dropbox and if intro to CFD. I kind of know this is a lot of different softwares that you guys have to learn during such a brief time, but since you are final year students, there is really the option for me, because you guys will have a lot more work in the upcoming semester, so we might as well do it while we have the time before exams and assignments load you guys with tension and stress. So I'm just going to go and then download the NACA 12 tin file, which I didn't need to do that, it's already in here in the JOM. Need all this. This is an accidental save of the data files. Also, once you do setup in Fluent, you don't need to do the same setup again and again. You can just go to File, Save Case, and it will save the settings you did, and you can load another mesh on top of that with the same settings. Just change a few things rather than doing all the setup again. I forgot to say that in the lesson 3. So I'm going to open ICM CFD. And I'm going to close CFD post and going to come back to CFD post later. Yes, close this. Okay, so I'm going to go to geometry, open geometry, go to the folder and geom, and the NACA 12 two-dimensional airfoil. Okay. Right, so control and right click. Yeah, control right click, and you can rotate. Turn on the points. No surfaces yet. Fine, so I'm just going to make a 3D wing from this rather than actually doing the one I showed you before, the on-era wing here, which you can try on your own after you do this tutorial, because there's no point in doing the same thing again and again. What I did here to be repeated for you guys. It's not just clicking buttons. The best thing is knowing how to apply the same techniques to another configuration. Okay, so I have a blunt trailing edge with spacing of 0.0088, so something like 0.01 meters, sorry, and a lot of points, so quite good curvature, quite good details using the points. Can turn off the points. Actually I need the points, so I'm going to keep that, and select all this, translate it, copy it, and do an Z offset of, but before I do that I want to see how long this is. 3.5. Okay, I need to scale this down to 1, so what I'm going to do is go to calculator and 1 divided by 3.5 is 0.2857, so I'm going to scale everything. Scale x vector 0.2, I forgot that, so let's go like 2857, y vector 0.2857, and apply. Okay, so now I should have a wing of roughly 1 here. Okay, so I'm quite happy with that. What I'm going to do is I'm going to produce an something that's has a aspect ratio of 5, a wing that has an aspect ratio of 5. So how do I do that? Basically aspect ratio is x length, or in this case it's not x, it's going to be the z length, or the span of the wing. That's my appropriate span of the wing, divided by chord length. So we know the chord length is 1, we want aspect ratio to be 5, so the span of the wing should be 5 meters. Fine, clear that. So I'm going to select all this stuff again and do a translate with a copy, saying that I want it to move in Z direction, so basically in this direction. So the arrow is in this direction, so it's +5. If I wanted it to go this way, I'll do -5. So click apply, and there we go. That's an aspect ratio 5 wing. Okay, so but there's no surfaces or nothing, so we need to make some curves. So let's just add everything to the part curves now. I'm just going to select this as curves. Later we'll change the names, and then just select that point. So I'm going to create curves from 2 points, and so I need to be a bit fast here. If you have doubts and concerns about the geometry part, just load into lesson 1 or lesson 2, and then basically just figure it out. So I created 2 curves there, and I'm going to select the center point, and this one, which I think is, okay, that's a bit hard to choose, so I'm just going to go here and select the center point as this one. Yes, and then I selected basically this one, so I'm going to go here and select the same thing. So okay, so I have some curves that defines my geometry. Now all I need to do is do some surfaces. I'm going to go in there and click this curve, So the curves are automatically joined by for some reason, and I'm going to see if it is visible or not. Surfaces on. So that's not correct. Undo that, and I will do a split in the curve. So segment by point, and I'm going to segment by this point. Okay, so now I have two curves. Same thing for this one, because we translated it here with a copy. Segment by curve, segment by point. This one. You can do other stuff too, segment by curve, where this curve meets this curve, so curve to curve intersection. Okay, so let's turn the points off just to make it easier for our eyes. Top surface, and select this, okay, great, select this, okay, and this, okay, and this, so it's just the simple 2 to 4 curve selection. I still have one more. Notice how I added everything to the part top surface, which is not very correct, but it's not a problem as well. We can later change the names and add to parts. Okay, so instead what I'm going to do is rename it as week. And one other thing that I remind you to do is always keep saving the project, because sometimes it just collapses, so you need to so let's say marker link 3D 0012, save it as stage 1. Okay, so now we have the wing. We need to create a domain for this. The best kind of domains are square domains, rectangular domains. For this particular configuration, I like this kind of domains, but spherical domains are not bad as well. Sometimes you just need spherical domains, but for this one, let's just represent a wind tunnel instead. So what I can do is I can just go to where I can either create curves and points and just do surface by surface, or I can just go into this very cool option called entity bounds, and I'm going to select this, all this stuff, and then I'm going to scale according to the dimensions on the wing. So the x length is, I know it's 1 meter, so I want it to be 50 times away, so 50 times x scale. Even though this is this will be something like 1.12 meters, because it's NACA 12, so 12% thickness of the chord length, which is 0.12 meters. So I'm going to what I'm going to do is just if I say 20 times, it's going to be a very small box, so I am going to say at least 200 times, because about 6-7 times this thickness is the chord length. So in y direction I want it to be 200 times, and in z direction, because z direction is longer, is 5, so I want it to be only 20 times. And then I click apply. Oh, before that I'm just going to say that give it a new name, maybe far field for now. Click apply, and then zoom to fit, and I have something like this, which is okay, but I want the x direction to be longer and z direction to be shorter. So one thing I can do is just go back there, undo that, and make Z as 15 and X to be 100 and click apply. And okay, that's not too bad. I'm quite happy with that. Okay, so I'm gonna save again. Now let's go into blocking. I'm going to say it's a 3D bounding box. Initialize with settings and project vertices. And click apply. And bam, some edges appeared. Okay, I'm going to turn off the surfaces just to show you what the edges. So it's just a rectangular domain, rectangular block. This thing called block at the moment, which is of to be honest no use. So we kind of need to associate. First thing we do is associate these vertices to the points. So I select this one, associate X vertex to a point. So associate this vertex, I select with right click and then again. So the points are not on. I'm going to tick on the points, turn on the points. If you are trying to do something silly, it usually gives a warning here. You can't pick points from the screen because they're not turned on the display panel. Okay, so once it's associated, you notice how the color changed from white to red. That means it's glued to the point. Okay, double click there, double click there, double click there. So you need to be a bit patient with this procedure. And all the vertices are aligned. Always you can go and turn off the geometry to see what's happening. Okay, so vertices are aligned. Now I need to associate my edges to curves. So this edge to this curve, this edge to this curve, and repeat, repeat. Once the edges are associated, they turn into green color, which I'll show you in a bit. So green means the edge is associated to a curve, and in a black background, white means an edge is associated to a surface. In a white background, black edges means it's associated to a surface too. So it depends on the background style you have chosen. I've chosen black just to make everything a bit more fluorescent and visible. So now all the edges are associated. I'm quite happy with that. So I'm just going to select the Z direction here, zoom in to see what's happening. So we got a wing here. The first thing we need to do is do some splits. So I'm going to go into split block and just select this edge and zoom in, and then just move this edge around until I'm in the tip of the leading edge, and then middle click, and then I'm going to also select this one. Okay, so I kind of have to zoom out and select this edge again for a vertical split. So I'm gonna move that to the tip. Okay, so that's okay. And then I'm going to do a split like this and a split like this. Right, so we have split it in this direction, but if we turn to the front view, which is not happening. Okay, so this is the front view, and we need to have some splits in this direction too. So I'm going to split it like this and like this. Okay. So when you do these kind of splits, these blue edges appear, which means they're internal, they belong to the volume zone. The white edges are to the surfaces. The green edges are associated to the curves. The blue ones are to internal volume. A lot of the time, something that's going to be very useful is going into blocking and index control. So it's like these divisions here that I have split. I can control how I'm viewing it. So I can go into this I direction, J direction, K direction, and when I do O grids here, it come O1, O2, O3, so it will be like O grid 1, O grid 2. So I'm gonna go into I direction 2 and then just reduce some stuff from here. In J direction also, I don't want to see all those lines, so I'm just going to do that and do that and do that as well. Okay, so now I have zoomed into this section, which is quite good. I want to get the shape of the wings to the edges, so I'm going to associate these three edges to these two curves. One thing I didn't do is projecting them, so let's do that again. Otherwise, you just have to manually use move vertex. Instead, let the software do it for us. Okay, so that moved. Do the same thing on the left side. Okay, somewhat define that. And we can turn on the points. Wherever you have a point, it's best if you associate that to a point, so it is okay. So what happened is, if I turn on surfaces bam, it's an error. So I'm going to turn off the far field. There's a split here. Turn off the surfaces. Okay. So notice that this edge, if I try to move this vertex, it moves. Okay, it's fine. My bad. I thought there was a split. It's a separate curve here. So I'm going to associate this vertex to this point, this vertex to this point. Zoom out. Do the same thing here. This vertex to this point, this vertex to this point, and turn off the points again. Associate these edges to these curves. Okay, we have something that's quite good, but there's no way I can associate anything to this edge here, which I kind of want to do, because I want it to be associated as well to define the leading edge. So I'm going to go split block and split here, and then just associate, sorry, wrong, this associate this one to turn on points again, this point, fine, and this one to this one. So first thing we are going to do is, after we do this, we'll work on the surface mesh, because that's more important. And if you have a good surface mesh, that means you have a good volume mesh, definitely. So I'm going to click this edge. Okay, I'm quite happy with that, but the problem is that it's not capturing the shape of the wing, so I need to do a bit more split. So I go in here, the edit edge and linear points, and I'm going to do a split like this manually, get the round shape of the leading edge, and do a similar kind of thing here, 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 here. And so it doesn't need to be all as the same, all the same as the airfoil curves, but as much as you can. So depends on your patience. So I'm going to turn off the points and do the same thing for here as well. Or I can just go to edit edge link edge and link this edge to this edge and this edge to this edge as well. But that doesn't work. So we can do this edge to this edge, this edge to this edge. So they're similar kind of edges, and they can copy the distribution from one edge to the other. Okay. So we have something that looks like a wing now, but remember that I did not associate these two. If I turn off the curves, I did not associate these two edges, the one on the top and the one on the bottom. But the one in the middle, we have nothing to associate it to, so we'll just associate it to the surface. Okay, so let's go again. Turn on the curves. Associate edge to curve, edge to curve. Okay, so turn off the curves, and even these ones. Sometimes you just miss these small edges by mistake. And zoom out. See if I have missed anything here. I have. So associate this edge, two edges to this curve. It's two because we have a split in the middle, which I did on purpose. It's no mistake. So the next part is going to be a quite tricky part, but just focus and just concentrate. So what I'm going to do is I'm going to say parts, create a part called solid. So remember all these things that was sorry, this is actually meant to be the whole block that we created before is meant to be called live or fluid. So it's the fluid zone. So this blocking we defined for the wing is still in the fluid zone. So we need to add that to a solid zone part. So I'm going to select this time, say the solid wing, and I'm going to select this one instead of this. This time I'm going blocking material create part. I'm going to select this block and this block. So the two blocks there, because we have a split in the middle, so it's two blocks. So I'm going to select these two, and notice how once we selected the solid structure, solid blocking, we have a new part here called solid wing, and the internal edges, the blue edges, have automatically been associated to the surface. Okay, so that's pretty great. All we need to do now is just do some basic parameters. So I'm going to say 100 copy parameters, apply, and then also here I'm going to say another 100. A lot actually, but fine, I want it to be quite accurate. Pretty much, yes. And I have a wing. This is great, but if I turn off the edges and the curves and then just zoom in, I still have some edges undefined. So what I'm going to do is I'm going to go in there and I'm going to say again edge parameters and turn off the premesh. It just takes a lot of data, so 10 divisions in this way and 10 divisions in this way. So if I did this 10 here and 10 here, because they're parallel to the ones in trailing edge, it will be automatically copied. You notice the 10 there. So I'm going to do premesh again. Okay, so pretty good, pretty good. But there's a lot of stuff that we need to still do. But I think I will, because it's already the video is over 30 minutes. I will talk about the volume meshing and improving the surface mesh, such as here we have, because as I said before, there's no ways to put perfect squares in a round domain. So these cells are kind of in a high skew manner. We can fix that by using something called OR grids, and there's a lot of ways to do OR grids. You can do the whole block or just select this face, and we will do that in the next tutorial or next video lesson. Okay.